we get going. So I'm going to start with the question you guys ask, and then we proceed after that. So the main idea is that, let me ask you a very simple question. Suppose I give you very simple, and please answer. Suppose I give you the following number. I factored it out. And I ask you, is this number a factor of 7? Sorry. Is this number a multiple of 7? Yes, no, quickly. And use chat to answer me. Is it a multiple of 7? It means this is the number here. Can I write it as something times 7? That's what it means. What do you think? Yes, absolutely, because I can write it as 2 times 3 times 7. That's what it is. Suppose I ask you the question, is this number a multiple of 2? Again, it means can I write it as something times 2? I'm talking about the same number, 2 times 3 times 7. Yes or no? Quickly. Absolutely yes, because I can write it as 3 times 7 times 2. So that's the idea of the least common multiple. So now I will go through the question you guys asked and we will proceed. So we are in section 1.5. Okay, and you ask about C and D. I will do, all of it just to make sure you guys are comfortable with that. So the question is find the least common multiple of the following. So A is they want the least common multiple of 7 and 2 plus x. I meant x plus 3. Okay, so what's the least common multiple quickly? So we don't know x. X plus 3 cannot be factored. So what's going to be the least common multiple very quickly? Please write on chat or in mute and say. Okay. Anyone? So let me put the question in numbers. Suppose I give you the number 7 and 5. And I tell you what's the least common multiple of those two numbers. Now 7, you cannot factor it basically. It's 1 times 7, and 5 you cannot factor it. So what's going to be the least common multiple is nothing more than the product of them. This is a multiple of 7 and it's a multiple of 5, and there is nothing smaller than that. So what's the least common multiple of 5 and x plus 3? Please help me out by answering the questions.
35.
And 35 in the problem I gave you, you're correct. But in this scenario, when I don't have numbers, it's going to be 7 times the quantity x plus 3. Yeah, or 7x plus 21, correct. Okay, so in this scenario, because I don't have numbers, I have variable, it's going to be the product, right? Part B. Okay, the question is find the least common multiple of the following. X squared plus 4x minus 21 and x squared plus 9x plus 14. So these are the two expressions, and they want me to find the least common multiple of those. The first way is we try to factor those expressions. It's just like I go back to numbers to remind you the process. Suppose I tell you find the least common multiple of 6 and 9. So what's the easiest way? You take 6 and you factor it if you can. Yes, we can. We take 9 and we factor it if we can, which is we can, 3 times 3. And then to build the least common multiple, you can start with any of them. You can start with 2 plus 3 times 3. And then you ask yourself, what shall I multiply this by so I get 3 times 3 as part of my factor? So I already have 1 3, I multiply by 3. That's what's left here. And this would be the least common multiple. It's a multiple of 9 because it's 2 times 9. It's a multiple of 6 because it's 6 times 3. So we factor each number. We start with any of them. Then you ask yourself, what should I multiply by? What's left so I can get the 3 by 3? I already have one of them. I should multiply by 3. So what am I heading? I'm heading into the following. You take every expression and you try to factor it. So this piece, how can we factor it? We look for two numbers. When you multiply them, you get -2. When you add them, +4. So what are the factors here? Can anybody, sorry, this should be 21, my apology. So can give me two numbers. When you multiply them, we get 21. When you add them, you get +4. 7 and 3. So 7 and 3 makes sense. X plus 7 minus 3. So these are the factors. Now we will do exactly the same thing and we factor those. Two numbers, multiply them, you get 14. Add them, you get 9. So 14, it's most probably 2 and 7. So we're going to write it x plus 2, x plus 7. So we start by factoring each expression. And now what's going to be the least common multiple? Okay, you start with one of them. It doesn't really matter. So we start with this. X plus 7 times x minus 3. And then we take the second term. Ask myself, which factor of this piece is missing? X plus 7 is already one factor. What's missing is x plus 2. So we multiply by x plus 2. So the least common multiple is going to be x plus 7 times x minus 3 times x plus 2. That would be the least common multiple. The reason we care about the least common multiple, first to add fraction, which is going to talk, basically I'm going to remind you of it a minute later on, and to simplify expression. That's why we need those ideas. So now this is a common multiple because I can write it as x plus 7 times x minus 3 times x plus 2. So it's a multiple of that. It's a multiple of this expression because I can write it as x plus 7 times x plus 2 times x minus 3. Okay, C. I want x to the power 3 minus 4x and x squared plus 4x minus 12. And the idea is to be able to do anything, I need to factor, if possible. Okay, I will factor the easy one first. Can we factor this term? Please, every one of you, factor it in front of you. I don't see you, but I trust that you guys will do what I'm asking you to do. Can we factor this term? And what are the factors? Two numbers, you add them, you get -12. Sorry, two numbers, you multiply them, you get -12. You add them, you get 4. So what are those numbers? 6 and -2, all right? So I will copy what you guys wrote. So it's x plus 6, x minus 2. Now, usually I check myself. X times x, x squared, minus 2x plus 6x plus 4x minus 12, correct. All right, so that's the easy one. Now I want this one to be factored, and we're going to do it very slowly, all of us. Okay, if you are factoring this expression, what would we do first? What do you see as common factor? Okay, so I will do this separately because it's a bit harder, but it's an interesting one. Okay, what is the first common factor you see between those two expressions? X, very good, X. So let's write what your classmate said. Because what is X cube? X cube is X times X times X minus 4X. So of course, X is a common factor. So, and that's the first one I'm going to get out of the picture, X. If I do that, what I will be left with? X times X, X squared. Yeah, I don't know if you wrote it correctly. I have a hunch you're right, but the writing is not correct. I stop here. Does this make sense? I factored the X, I got X squared minus 4. Now, this piece here, we've talked about it in class last time. And what did we call that? This will come up a lot with us and with you eventually. And yeah, I know. That's called the difference of square. That I definitely want you to memorize because it's very useful. The difference of square. What's the difference of square? Let us remember what it was. Tells me the following. In general, if I take the statement a square minus b square, I can factor this as a minus b times a plus b. So it's very important. That's a minus, that's a plus. So how can I apply this idea to this expression here? And here, what's playing the role of a is the x. So this would be written as, this is equal to x times x squared minus the 4 is the 2 square. So that's how we're seeing it like this. So now I want to factor it out using this rule. So let's factor it out using that rule. So this is going to be equal to x times the quantity x minus 2 times x plus 2. It's a very good exercise in factoring. Very good exercise in factoring. Okay. And now I can go back to the initial problem and then finalize the least common multiple. So now I rewrite what I had in mind, what the problem asked. They had this expression and they had this expression, minus 12. All right, we factor like we did. So this became x minus 2, x plus 2. This, you guys told me, x plus 6, x minus 2. So what's going to be the least common multiple is going to be what? You start with any of them. I'm trying to read what you guys are telling me. X plus 2, x minus 2. You're missing one term. The one who wrote Shane, I guess you're missing a term. What do you think it is? X, exactly. So what's the least common multiple? You start with this, x times x minus 2, x plus 2. And then you look here, which factor is missing? We have the x minus 2, what factor is x plus 6? And that would be the least common multiple, okay? So one more and the last question, and then we proceed in using those. As I said, we use them when we add fraction. Otherwise, adding fraction would be a little bit problematic. Now, the last one I had, you guys ask, is part D. And it's y squared plus xy minus 2x squared. And y squared minus x squared. Again, we look at them, we try to factor them. If we cannot factor, we multiply them. If we can factor, we do our best. I start with this expression. Do we know how to factor this expression? Something squared minus something squared. So whenever you see something that's a difference of square, slowly, I want you to kind of internalize it the best you can. So difference of square, that's a minus. So this will be y minus x times y plus x. And then nothing else. Very nice. Now this piece here. This is harder. We can do it by trial and error if you want. So let's see what I can do here. Okay, trial and error. I'm gonna start, should be y, and minus or plus you will decide. So I can think about it this, I want two numbers. When we multiply them, we get minus 2x squared. Anybody do it by trial and error. I don't want you to know a rule in this case. What do you think is going to be? If I want two numbers, so I'm going to try 2x, and I'm going to try x. And as I said, I'm doing it by trial and error. And I said, does this work? Am I correct here? So let's see. I'm going to multiply them out. So I do it by trial and error. Okay, does this work? You guys help me out. Y times y squared, plus minus y times x, xy, plus 2xy, plus minus 2x squared. So this would give me y squared plus xy minus 2x squared. So the factorization, the way we factored is correct. So what's going to be now the least common multiple? Again, we start with any of them. And we move here. Which factor do I have in here? I have the y minus x factor. The second one is going to be y plus x. And that's the least common multiple. Any questions before I move on? All right, today the idea is to review fractions, and at the end we go back to function, because as I said, the book is putting developing algebraic skill at the same time with functions. So we're going to review fraction. Hello, I have an appointment, so I will have to leave at 1:30. Thanks, Brianna, for letting me know. All right, so today we're going to review fractions, and then at the end of the lecture, I will bring functions back to the picture. Simplifying fraction. One of the mistakes sometimes occur when we're simplifying fractions. So simplifying fractions. Okay. Suppose I have the following. Okay. I have 2 times, that's times a, divided by 3 times a. All right, so I'm multiplying. Okay, thanks, Cece. All right. In this case, if I'm multiplying by the same term, I can simplify the a and the a, and this would give me 2/3. All right, so for example, 2 times 5 divided by, let us say, 3 times 5. This is, we can simplify the 5, and this would give me 2/3. Now my question is, however, suppose I have 2 plus a divided by 3 plus a. So be very careful, I have a plus and a plus, not multiplication. Can I simplify this expression? Yes or no? Please, I would like answers. Is there a way we can simplify? Ideas? The A cancel, and the answer is no. Definitely not. So this can't simplify, and I will show you example. Can't simplify. Means if I have a plus, we cannot simplify. So for example, those can't. We cannot cancel the A. Can't cancel A. Because if I, instead of A, I give you a number. Suppose I have 2 plus 5 divided by 3 plus 5. Okay, if I cancel the 5, I don't know. I make this into 1. This is 3 over 4. But this is 7 over 8. 7 over 8 is definitely not 3 over 4. So when I have addition, I cannot cancel. The only time we can simplify if I have multiplication. Okay, so let me write this down. In a fraction, that's crucial. Only terms that are common factors of numerator and denominators can be simplified. They have to be common factors of numerator and denominator can be simplified. And denominator can be simplified only. So in a fraction, only term that are common factor, it means they are multiplied, they can be simplified. So what I mean by that, one more time, it means if you have A times C divided by A times B, you can simplify by the A and get C over B. If you have A plus C divided by A plus B, this can't simplify. Crucial in working with fraction. So I'm going to give you several expressions and we're going to simplify them. So the question is how to simplify a fraction. So now how to simplify a fraction. So to simplify a fraction, we look for common factors between numerator and denominator. Numerator and denominator. Okay, so to simplify, we have to go after common factors. So simplify the following expression. All right, please work with the problem with me. I'm going to start with the easy one. 4 over 6. How can we simplify it? The only way to simplify it, we need to find if there is any common factor. So to be able to do that, we factor the numerator and denominator if possible. All right, how can I factor this? That's 2 times 2 over 2 times 3. 2 and 2, they are multiplied. This is 2/3. So that's the idea of simplifying. So I'm going to give you another problems. Suppose the question is simplified. 2r over 3r squared, where r is a number. Okay, if I want to simplify this, it's going to give me what? Can I simplify here? Okay, the numerator is 2 times r. The denominator is 3. Now r squared is basically r times r. Now, r is multiplied by the numerator. R is multiplied. This r can factor, which will leave me with 2 divided by 3r. All right, question number 3. Suppose I give you the expression 2 plus r divided by 3 plus r squared. Can I simplify this expression? Yes or not? No, absolutely not. Can't simplify. I cannot factor the numerator, pure and simple. There is nothing in common. R and R cannot be simplified because I have a plus in between. All right, I'll give you one more problem, 2 more problems. I want you to simplify the following expression. Simple one, x squared plus 2x divided by, let us say, x squared minus 2x. I want to simplify this expression. All right. Make it easier to work with. How can we simplify? We try to factor numerator and factor denominator if we can. My question is always if we can. If we can't, we just move on. All right, can I factor the numerator? Is there any common factor in the numerator? Yes. The factor is obviously the x. So this would leave me with x plus 2. Can I factor this? Yes. X minus 2. Now, can I simplify the x and the x? Yes or no? Yes, because it's multiplied. It's multiplied. X, I end up with x plus 2, x minus 2. So that's how we simplify a fraction. We factor if we can, and then the only way we can simplify if it's a common factor of the numerator denominator. Otherwise, it's absolutely false. All right. Now we are going to review the idea of adding fraction. Okay, so as I said, it's a quick review. So addition of fraction. So I always start with a very simple scenario, and then I will make it a little bit harder. So let us say I'm adding 1/3 plus 4/3. That's the simplest possible scenario. Now, because I have the same denominator, a third plus 4/3, I can combine numerator, giving me 5/3, because the same common denominator. Now, if I don't have that, suppose I tell you find 1/3 plus 4/5. So as you guys know, in this case, different denominator, there is no way I can combine those two expressions. The only way is to find what you guys call the least common denominator. So what's the least common denominator in this scenario? The least common denominator is basically the least common multiple of 3 and 5. So the least common denominator here is 3 times 5, which is 15. So now we proceed. Okay. I have a 3 in here. Ask myself, what should I multiply by to get the 3 times 5? So that's going to multiply the denominator by 5, the numerator by the same one. Plus 5. What should I multiply by to get the 3 times 5? I should multiply by 3. Multiply the denominator, we multiply the numerator quickly. Now I have 5 over 15, that's my common denominator, 12 over 15. The same denominator, we can combine our numerator, giving me 17 over 15. Okay. All right. Now let us say one more example with numbers, and then we move to variable. Suppose I have 1 over 6 minus 5 over 9. Again, different denominator. We have to find a common denominator or the least common denominator. So the least common denominator is basically the least common multiple of 6 and 9. Quickly, it's 18. We did it in class before. That's 18. We factor each one of them and we proceed. So this would give me the following. Now 6, if this is 18, 18 is 3 times 6. So 6, I have to multiply it by 3 to get my 18. I multiply my numerator by that. The 9, I have to multiply it by 2 to get my 18 by 2. So finally, I will have 3 over 18 minus 10 over 18. Now I can combine my numerator. I'm safe, which will give me minus 7 over 18. Okay. All right. Now let us move a little bit to variable because that's the idea in this course. Just work with variable. So suppose I give you the following expression. 2 over x plus 6x over 5. Okay. And the question is, add this expression and simplify. The approach is the following, the same. These are the denominator, which are very different. So what's the least common denominator here? It's the same thing as the least common multiple of x and 5. What's the least common multiple of x and 5? 5x. There is nothing in common between them. It's 5x. So that's going to be my common denominator. So x, that should be multiplied by 5. That should be multiplied by 5. Plus, this 5 has to be multiplied by x. It means my numerator has to be multiplied by x. So this would give me 10 over 5x plus 6x squared over 5x. I am safe. Now I can combine this. Okay. 2 more problems along the same line. 2 over x plus 5 over x squared plus 1. Okay. Again, back to you. What's the least common denominator in this scenario? So the least common denominator is the same thing as the least common multiple. Now this is 1 is divided by 1. That's how it's the least common multiple of x and x squared. So the least common denominator of x and x squared is basically the least common multiple of x and x squared. Okay, so what's the least common multiple of x and x squared? X, when I factor it, it's x. There is nothing I can do about it. X squared is x times x. So what's going to be the least common multiple? I am reading. I'm not seeing anything. So how we construct the least common multiple of that? We start with any of them. This one, and I say, okay, what should I multiply by to get x times x? I should multiply by x. Then the least common multiple is going to be x times x, or it's going to be x squared. Okay, now let us do this. So it's going to be equal to x, to get my least common multiple, has to be multiplied by x. It means my numerator has to be multiplied by x, plus x squared multiplied by 1. So this would remain x squared, plus 1 has to be multiplied by x squared. It means my numerator has to be multiplied by x squared. And now I have a common denominator because x times x is basically x squared. Now that I have a common denominator, I can combine the numerators. It's 2x plus 5 plus x squared, the whole thing divided by x squared. So that's how we simplify this expression. Please ask questions. Okay. Now, another example along the same line. Suppose I give you x over x minus 2 plus x plus 1 over x squared plus 2x minus 8. I know that it looks horrific, it looks nightmarish, but we have to express it. All right. It's two fractions. There is one way out. We look for the least common denominator of those two expressions. So least common denominator of x minus 2 and x squared plus 2x minus 8. All right, I'll give you a minute to tell me what do you think is going to be the least common denominator, and then I will work it out with you very slowly. Please, I don't see you, but just do it for yourself. Remember, you have to start by factoring out this term so you can see the common factors between them. So I'm going to add one more step here to make it easy for us. So I know that if I want to find the least common denominator, I need to factor. This one I can't factor. This term could be factored into, you guys are faster than me in this. What are the factors of this term? X minus 2 times x plus 4. So to find the least common denominator, usually you look at your denominator, ask yourself, can you factor it? So this could be written x minus 2 times x plus 4. So what's going to be my least common denominator? It's exactly like the least common multiple. It's the same thing. I start with any of them and ask myself, what should I multiply by to get the second term? I should multiply by x plus 4 because I already have the x minus 2. And that would be my least common denominator. And now I proceed, I'm back here. No, it's the product. The least common denominator is the product, x minus 2 times x plus 4. And now what should I do here? Okay, this is x minus 2. What should I multiply by? I should multiply by the x plus 4. I multiply the denominator, the numerator, plus. This expression, I don't have to multiply by anything because I have it. So this remain the same. And this is x plus 1. Okay. Now I do the math and I combine. So this is equal to the following. Okay. All right. My common denominator is x minus 2 times x plus 4. Numerator is x times x plus 4 plus the quantity x plus 1. Now, the denominator, my advice to you, just always keep it factored. I don't want you to distribute the denominator. Usually, I want you to distribute the numerator. So the denominator, I'm not distributing, I will keep it like this. The numerator we usually distribute. It makes it much easier. So let's do that. X times x, x squared, plus 4x, plus x plus 1. And finally, we simplify as much as we can. X squared is x squared, 4x, 5x, plus 1. And the denominator would be x minus 2, x plus 4. And that's the answer we get. Okay. All right, last problem is the following. Again, adding and simplifying. Minus 1 over x squared minus 4. All right. And I want you to give me the least common denominator is. Remember, to find the least common denominator, we try to factor each one of them. This I can't, this I can. Okay, I want you to give it to me. I give you 30 seconds. I'm going to keep quiet. Okay, anybody else? Yeah, absolutely correct. That's going to be the least common denominator. So we're going to factor. So the least common denominator of x minus 2 and x squared minus 4. All right, I have to factor each one of them. So by now we, in a way, done x difference of square, that's x minus 2 times x plus 2. So the least common denominator is going to be x minus 2 times x plus 2. All right, so now this is equal to over x minus 2. I have to multiply it by the x plus 2. We multiply by x plus 2 minus. This one, I don't have to multiply it by anything, so it stay whatever it is. It stay a 1. Common denominator, the same denominator. That's the only time we can combine numerators. That's why we do all this. So finally, I will have x times x plus 2 minus 1 over the quantity x minus 2 x plus 2. Okay. So finally, as I said, I do not touch the denominator. Usually, I advise you against it. It's the numerator that we simplify. So now I'm going to distribute x times x squared plus 2x minus 1. End of the problem. All right. So how to combine expression if we have like x's and stuff? You factor each denominator as much as you can. Once you factor your denominator, you look for the least common denominator, and then you proceed like as if you had number in a way. All right? Okay. Now we're going to review very quickly. I remind you the rule of multiplying and dividing fraction, and then I will bring functions back to the picture. So now multiplication of fraction. Multiplication of fractions. Okay. All right, you guys try to remind me. If you have one fraction, a over b, and you multiply it by another one, c over d. Quickly, how do you multiply fraction? Okay, we multiply across. A times, no. You multiply across. A times c divided by BD. You multiply across. Okay, so A over B times C over D. You multiply across. That's how we multiply fractions. So for example, quickly. Suppose I have 2/3 times 4/5. How you multiply? We multiply across. 2 times 4 divided by 3 times 5. 8 over 15. Now, example number 2. Suppose I have 5 times 6 over 7. This should give me how much? Okay, can you guys give me the answer on bright space? Sorry, yeah, on chat, please. Quickly. 30. exactly. 5 is 5 times 1 times 6 over 7. We multiply across 30 divided by 7. So we have to be very careful how we multiply fraction. No, so that's multiplication. There is nothing more I can tell you. That's how we multiply. I'm just reminding you the rule of the multiplication. Now, before I move any further, let us recall a fact. And this is something that came up in your quiz. Suppose I have a quantity a times b to the power 2. This is equal to what? What's a times b? Is a times b times a times b, correct? So if I flip those around, so this is going to give me how much? A multiplied by a, so I'm just commuting them. So it's going to be a times b times b. It means a squared times b squared. So the quantity ab squared is a square. So you square this, you multiply it by b squared. And this generalized. So if I have, by the same idea, is I have a times b to the power 3. This is a to the 3, b to the 3. So you raise every one of them to the power. So let us practice something very easily. So for example, if I have the quantity 2t squared, this should give me how much? You have two ways. Either you write 2t times 2t, or you remember this is this term square times t square. That's 4 times t square. Okay. Now, part 2 is, let us say I have a fraction, a over b to the power 2. So it's going to be equal to what? A over b times a over b. Now, based on multiplication of fraction, it's a times a divided by b times b. So if you have a over b squares, so quantity a over b square is the numerator square divided by the denominator square. So you square each one of them. A over b to the power 3 is the numerator to the power 3 divided by the denominator to the power 3. So let us say, suppose I tell you to simplify the following expression. 2 over x to the power 2. This is equal to what? Okay, 2 over x, the whole thing to the power 2. This is equal to what? You either memorize the rule, it's 2 squared over x squared. It means 4 over x squared. And if you ever forget it, you say, you know, this is 2 over x times 2 over x. And we should always know how to multiply fraction, which is 4 over x squared. Yeah. Now, 3 over 4 to the power 3 is the same story. It's 3 to the power 3 divided by 4 to the power 3. And now you just pick up your calculator, or those are easy, which is 6127 divided by 64. All right, the last thing I would like to remind you of is the division of fraction. Division of fraction. Let's see how the rule work. What's you have a over b, one fraction, divided by another one. Okay? So this is equal to what? A over b, you multiply it by the reciprocal. Remember, that's a division. We're not multiplying here. So that's basically the rule. Oh, okay, let us practice this a little bit. So suppose I ask you to evaluate the following. All right. Evaluate 3/4, sorry, divided by 1/6. Okay. So this is equal to what? Okay. We use the rule. 3/4 times 1/6, 6/1. And now we multiply across. So the 3 times 6 divided by 2, divided by 4, it means 18 divided by 4. But now we know that this expression could be simplified because 18 is 2 times 9 divided by 2 times 2. So it's nice to be able to simplify, which will give me 9/2. Exactly. All right. Question number 2. I want you to perform the following. 3/4 divided by 6. How much you guys getting? 1/8. Lydia getting 1/8. Let's see if she's correct. So that's one fraction. To 6, you can think of it of 6/1. It means that's 3/4 times 1/6. It means 3/24. We multiply across. And then 24 is 3 times 8. Now, multiplication would leave me with 1/8. Absolutely correct. Now, let us move to fractions where you have, symbols. So suppose I give you the following. This is in R here, divided by R/S. Okay, so this is equal to what? Again, one fraction divided by another. We treat it exactly the same. It's 1/R times the reciprocal, S/R, which will give me 1 times S divided by R squared. Right? Now, sometimes fractions become a little bit, harder, not harder, but a little bit more complex. So suppose I give you the following expression. And I ask you to simplify it. So that's 1/x. And I'm going to divide it by 2 plus 4/x. Okay, so it's tiny bit more complex. And I ask you to simplify this expression. How do you think can we simplify it? I want you to stare at it a little bit and see what do you think. Least common denominator. Okay, Ashley, for what? Let's be very precise.
Can you solve the addition side of the division before you divide it?
You have to, absolutely correct. There is one way out. As your classmate said, first we have to simplify this expression. So first we have to perform this addition before I can touch this expression. So Ashley is absolutely, whoever answered is absolutely correct. So first I have to work with that. Once I fix this, I have to make it into one fraction, and then I can proceed and divide those two fractions. All right, 2 plus 4/x. Do we know how to find a common denominator here? So I will do that on the side. So first, because that's the first time, I'm going to simplify this. And then I will go back to my problem. So let us simplify this. This is 2/1, as we know. So the common factor here, the least common denominator is x. We don't have anything else. So this will become 2x over x plus 4 over x. I open my parentheses for this piece right there, which will give me 2x plus 4 divided by x. So the first step, I have to basically simplify this piece. Now that I simplify it, I go back to it. So this would become equal to. So exactly that's the expression, quantity 1 over x divided by the quantity 2x plus 4 divided by x. Now I have a fraction divided by another one. I can use the rule that you guys know. So it's 1 over x multiplied by x over 2x plus 4. Okay, and now we multiply. So this is x divided by x times 2x plus 4. Are you with me so far? Now, can I simplify the x and this x? Sometimes I can't. In this case, can I simplify those two x's? This is basically x times 1. So it's multiplied by 1. And this is x. So this would leave me with 1. So now I can simplify because this x is multiplied 1 over 2x plus 4. And this is a way, way, way easier expression than the one starting with. All right, one last example as a review. Suppose I have 1 over x plus 6 divided by 4. Again, my question is to simplify this expression. The only way to simplify it is as we did before. My denominator is complex. I want to find a common denominator here so I can start working with that expression. So this will give me equal to what? All right, let me open the parentheses for the numerator, and then I plug it back in. So I'm going to do it on the side just to be very clear with that. Now here, 6 is like 6 over 1. So the common denominator is going to be x. So it's going to give me 1 over x plus 6x over x, leaving me with 1 plus 6x over x. Now this is a more simplified version, and now I go back here. This is 1 plus 6x over x, and this is a 4. So this would give me the following. 1 plus 6x over x times 4 is 4 over 1, 1 over 4. At this stage, I'm just multiplying, so this will give me 1 plus 6x divided by 4x. And now can I simplify the x and the x? Yes or no? I have x here, x here. Can I simplify them? Yes, 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 yes. No, 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 no. Why no? Why no? Let us remember, when can we simplify? We can simplify in one scenario only, when the x is a factor of the numerator and denominator. Is x a factor here? We have a plus. The only time we can factor is if you have x times over x times. That's when we can factor. That's the only scenario. If I have x plus something divided by x plus something, no way we can factor this expression. So here, I don't have x like a factor of the numerator. It's added 1 plus 6x. So I cannot simplify it with this x. I can only simplify it if it's a factor of the numerator and a factor of the denominator. It is in the denominator, but it's not in the numerator. We cannot simplify. So that should be the answer. We cannot touch it. Are you with me a little bit? Yes? Are you with me? Very good. All right. So this is our revision of fractions. Now let me just go back a little bit to functions and kind of build in functions one more time. So back to functions. Nothing is going to be new for function. It's just I'm going to bring fractions into it. So back to functions. So this will put me in section 1.6, but don't be afraid. 1.6 is something we've seen, but a little bit more algebra in the scenario. So I'm going to take the following function. Let f of x, I have the following rule. F of x equal x squared plus 3x plus 2. Okay, so I have a rule that takes an input x, and to this input, it associates x squared plus 3x plus 2. So the first answer the following question. So first, let us evaluate f of minus 2. Okay, so it's the same thing like we've done before, but as I said, more algebra. So my function is you give it an input x, it's going to do the following to it. It's going to square it, then plus 3 times whatever you give it, plus 2. So f of minus 2 will be equal to, instead of x, I put minus 2, plug in minus 2, plus 3 instead of x, minus 2, and that's it 2. That's it, I don't touch it. So minus 2 squared is minus 2 times 2 is a 4, minus 6 plus 2. 4 minus 6, that's going to be minus 2 plus 2, which is equal to 0. All right? B, I want you to evaluate f of 3 over 4. And this time you evaluate and simplify as a fraction. All right? So let's see what f of 3 over 4 is. Whatever you have x, is 3 over 4. Plus 3, wherever you have x, 3 over 4 plus 2. Okay? And now we are going to use whatever we've learned a minute ago. Okay, 3 over 4 squared gives you what? Is equal to what? 3 squared divided by 4 squared. Okay, which is 9 over 16 if you want. So that will give me 9 over 16 plus 3 times 3 over 4. We're multiplying two fractions. 3, as you remember, 3 times 1. It's 3 times 3, which is in 9 over 4 plus 2. And now I want the answer as a fraction. One of the things I'm going to push you is to give me answers not as a mixed fraction. I want it as really a fraction because math works better with fraction than mixed fraction. All right, so now this is equal to. I have to combine those. I need my least common denominator. And my least common denominator is going to be 9 over 816. Okay, sorry. Yeah. All right. What's going to be my least common denominator here? I have 16, which is 4 times 4, and I have 4. So what's the least common denominator between 16 and 4? 16. Because 16 is 4 times 4, and 4 is 4 times 1. So 4 times 4 is the least common denominator. So now let us proceed. Plus the 4 to get to 16, I need to multiply it by another 4. And now this is 2 divided by 1, so I need 16 here, and this would be multiplied by 16. Now that I can secure my common denominator, I start combining numerators. That's a 9 here, plus 36, plus 2 times 16, that's give me 32. And now I just add those numbers all together, and denominator is 16. This give me 2 and 6. 2 and 6, let's give me an 8. 8 and 9, that give me 17. And this would give me 77 over 60. Okay? All right. Now, see, as I said, we're doing the same thing. I'm just, putting fraction into the picture. Now, expression of f, find an expression. I'm not asking you to solve this time. There is no solving. Find an expression for f of 2 plus t. It's the same function. I'm always working with the same function. What does it mean finding an expression for f of 2 plus t? It means you plug in 2 plus t for x. Whatever that is x, you plug in 2 plus t. So this is going to be equal to, I'm not solving, I'm just finding an expression. Whatever that is x, 2 plus t. Whatever that is x is the quantity 2 plus t. And then 2 is a constant. I just removed. And now we need to simplify this expression. And this is a good time for me to point out a mistake that was very, very, very prominent in your quiz. All right, the mistake is this. If I have the quantity a plus b squared, let's see, this is equal to what? This is the quantity a plus b times the quantity a plus b. Means that's the following. If I distribute, is a times a squared, plus ab, plus ba, plus b squared. It means this is a squared plus 2ab plus b squared. That's what the quantity a plus b squared. The very common mistake, what actually was done almost across the board in class, was the following. A plus b squared, you cannot distribute the square. It's false. It means this is not the quantity a squared plus the quantity b squared. You can't distribute the square. It's not correct. So a plus b squared is, you can memorize the formula, a squared plus 2ab plus b squared. If you don't want to memorize it, I don't actually care. You just multiply them by each other. What I don't want you to do is to distribute the square. In multiplication, in addition, you cannot distribute the square. You can distribute the square only if you have a multiplication. That's when it works. This is absolutely doesn't work. All right. So why I am addressing this subject? I'm addressing this because I have the quantity 2 plus t to the power 2. So 2 plus t squared, it's not, absolutely not, 2 squared plus t squared. It means 4 plus t squared. This is not correct. Okay. I mean, you can think of numbers. Usually, thinking of numbers will help you. If I have 2 plus 3 to the power 2, this is 5 squared. This is 25. It's not 2 squared plus 3 squared, which is 4 plus 9, 13. So it doesn't work for numbers. It doesn't work for variables. So with this in mind, let me find an expression for this. What's 2 plus t squared? Again, I will do it again. It's 2 plus t times 2 plus t. Okay, so it's going to be equal to, distribute. It's 4 plus 2t plus 2t plus t squared. Plus, I distribute 3 times 2, 6, plus 3t plus 2. Final step, I will combine like term. T squared, 2t plus 2t is 4t plus 3t 7t. And 4 plus 6, that's it, 10. 10 plus 2 is equal to 12. End of the problem. So here I'm not asking to solve, I'm just asking to find an expression. All right. Now the following. Again, find an expression for f of 2 over t. Again, let's see what my function does. My function takes the input, square it, 3 times the input plus t. So I'm going to do exactly the same. The input is 2 over t. So what's of that? It's the input, whatever it is, it squares it, plus 3 times whatever the input is, plus 2. That's the setup. And now we have to simplify. Absolutely, we have to simplify. It's equal to. Okay, based on what we did, the quantity 2 over t squared should be equal to what? Because to simplify, I have to start showing my fraction. This should be equal to what? 2 over t squared. This is square the numerator divided by the denominator square. So this is going to be 2 squared, which is 4, divided by t squared, plus. Now we have to multiply. This is basically a 1. That's 3 times 2, which is 6, divided by t, plus 2. So we simplify. Now we have to find the common denominator, the least common denominator. What's the least common denominator here? This is 1, so I will take care. We have t squared and we have t. T squared is just t times t, and t is t. So the least common denominator is going to be t times t, or t squared. That should be our least common denominator, because we start with any of them, t times t, and then this factor is already in there, so I don't have to add anything for it. And now we finally proceed. 4 over t squared, that's t squared, I don't touch it, plus. Here I only have t. If I want t squared, I need to multiply by t. I multiply my numerator, plus. This is 1. If I want t squared, I have to multiply this by t squared, and this will be multiplied by t squared. And now I have the same denominator. I can start combining them. It's a 4 plus 6t plus 2 squared. Okay, so what, like as we did before, but we're just trying slowly to incorporate more fractions into our expression. Right. Again, one more question. I'm working with the same function, nothing different. So more question. Okay, here I'm going to write the function so I can, so my function was f of x equal x squared plus 3x plus 2. Okay, and now my questions is going to change a little bit. So my question now is find all values of x. Now the book is using the letter C, so I'm going to use the letter C just for the familiarity. All values of C, such that f of c equal 0. Okay, so I did the question. Find all values of c such that f of c equal to 0. This time, I have an equation because I'm going to find, so I'm going to set this. So I'm going to find all c such that which value of c, when I plug it into the function, I get a 0. This time, this is an output. And my question, which input will give me an output of 0, which input will give me an output of 0. So now the question is, we need to solve. Now, how to solve this equation? How do we solve it? Do you guys remember? Any ideas?
You get C alone.
We can't in this case because I have C squared. Okay? So the idea is factor. All right? Factor this expression. Now, do we know how to factor this expression? Do we know how to factor? C squared plus 3C plus 2, 2 and 1, and C plus 1. Okay, so let me make sure. C times C squared plus C plus 3C plus 2. So whenever equal to 0, we factor it. What's the benefit of factoring? If this product is equal to 0, this means that either this is 0 or this is equal to 0. Because the only way, if you have two numbers, if you multiply them, the product is 0. This can occur if A is 0 or B is 0. So the only C's that will make this product 0 are the C that make the first factor 0 or the second factor 0. If this will give me C equal minus 2, and this would give me C equal negative 1. Okay, so whenever we have a scenario where I have a C square and C, we cannot isolate the C. It's basically impossible. The way to do it is to factor this expression, set it equal to 0. Once you do that, you argue as follows. The only C's that make this product 0 are the C that make the first factor 0 or those that make the second factor 0. If C plus 2 is 0, it means C is minus 2. This gives me C equal minus 1. And now we can check our work. If C is minus 2 and I plug C in here, do I get a 0? So let us check. Suppose I take C to be minus 2. And I plug it into f of C. Do I get a 0? So f of C would be minus 2 squared plus 3 times minus 2 plus 2. That's a 4 minus 6 plus 2 equal to 0. Now, let me check if minus 1 make f of c 0. What is f of minus 1? Is minus 1 squared plus 3 times minus 1 plus 2. 1 minus 3 plus 2. This is equal to 0. Check. Okay, so whenever I have c squared, c, and a constant, the only way we're going to be able to solve is to factor z equal to 0. Once we do that, the product is 0 if the first factor is 0 or the second factor is 0. Once we do that, we can solve the equation. Okay. All right, of course, that's it for today. I think I recorded the lecture. So I will put the recording on Brightspace. And I'm gonna give you homework as you expect. And your quiz on Wednesday will cover, everything I did today. Basically, a fraction, how to work with them. And I will give you a function along those lines. And I will make you work with function, but I will have more fractions when I give you the function. Okay? All right, thank you guys. And hopefully I'll see you on Wednesday. All right. If you have any question, you can stay online if you have any questions. Okay, thank you. Okay, bye-bye, guys, then.
Professor,
Yes.
Did we take attendance or anything?
Yes, I meant Zoom takes it automatically.
Oh, okay. Okay.
Yeah, Zoom takes it. So I have a list of the student who showed up.
Okay,
Any
perfect. Thank
other
you.
questions? Okay, bye and see you on Wednesday. Bye, guys.